What is going on, guys? Welcome back to another video for the SQL tutorial series here on Neural 9. In today's video, we're going to cover advanced queries, meaning more than just a basic select from where. We're going to talk about ordering, we're going to talk about grouping, we're going to talk about aggregate functions, and more. So let us get right into it. Alright, so we're going to talk about more advanced SQL queries in this video today. Advanced in this context meaning not just the basic select from where statements that we already covered, but we're going to add some more elements to the queries in this video today. And we're going to use this people table here with this sample data. I prepared all of this before the video because this is all stuff that we already covered, so it's nothing new. The people table has an ID, name, age, height, gender. We have an auto increment here, an enum here, and this is the sample data. You can choose whatever sample data you want. I just made up some values so that we have something to work with. And the first keyword, the first element that I want to talk about here is the distinct keyword. Now, maybe as a reminder here from the first video, from the first episode, the basic structure of a select statement is select, then what you want to select, so either column names or an asterisk for everything, so we could say pname, ph, from then the table name, and then we can specify a where condition optionally, so where age is above 30, for example. So if I run this, first of all, of course, we need to drop the table, create a new table, insert the data, and then select. This is what we already know about, nothing special here. So what we can do now here is we can add a keyword called distinct, and distinct basically goes through the results and eliminates duplicate rows. So if I have 10 different people called Mike with the age 20, I'm only going to see one time Mike 20, and I'm going to see all the other names and age combinations only one time. So I'm going to show you an example here. If I say distinct for this query here, nothing is going to change because I don't have any duplicate rows. I don't have anything, and I also didn't have anything before where I have duplicates. I can also eliminate the where statement, and all these rows are unique, so we don't have anything that can be called a duplicate. We do have the same age in a couple of rows, but that doesn't matter. If I only print the age, so if I say select ph from people and I run this, then it's a different thing. So now I have 55, 55, and 55. Those are duplicates. So if I now say select distinct age, we're only going to get one time 55. So you can see that we only get this once. And you can even see that this is the case in a more extreme way if we go for the gender, because then we see male, female, female, male, and so on. And if I say distinct, we're going to get only the unique entries here, male, female. So this is what the distinct keyword does. Now, what we can also do is we can apply in the where statement. So this is now a different keyword. We can say select, and then we can say, for example, everything. So let's go with an asterisk here, select everything from people. But I want to say where. And our comparisons or conditions that we have here, or that we had here up until this point, were basic comparisons like greater than, equal to, not equal to, less than, stuff like this. And what we can also do is we can ask for membership in a collection. So we can say select all the people where the age is, so where ph is part of the following list. So I can use the in keyword to specify here the ages, the specific ages, not a range, but specific ages, for example, 55 and 65. And then I would only get people that are either 55 or 65 years old. That would be the in operator. We can also, for names especially, this is interesting, we can also use a like operator. The like operator doesn't match the string exactly. So if I say here pname equals Mike, then this is going to be the exact match. If I have MIK, this is not going to work. So this is the exact comparison. Now I can also say like, And then I can use percentage symbols here to say something like the name has to start with an M. In this case, Mike is the only one, but if I say J, for example, we can see John, Jeff, and Jim. Or I can say has to end with an A, so %A, Anna, Lisa, Angela. Or I can say something like has to have an N in between somewhere, so %N%. And then we get all the names that contain an N in between, not in the beginning and not in the end. Or actually in the end as well, because % can also be just nothing. So this is the like operator. Another thing that we can do, and I'm going through the list right now. So I'm going to list a lot of things here and cover them briefly. So what we can also do is we can use aliases. Now this is more of a representation thing, so this is not really functional, but I can say, for example, pname as name with a capital N maybe, and I can also use quotation marks for this, like this, so as name, and then ph as h from people, and then I would get name and h as column names instead of pname and ph. And this is also something that we can do. Now, a category of things that we can do here are aggregate functions. We can apply aggregate functions on in the query. So we can say, for example, select ph from people. This would just list the ages, as you can see. But I can also say sum up the ages. So I can say select sum from ph. And in this case, it would just sum up all the ages. We would get this as a result. And of course, I can also say as, and then I can provide a string h sum. There you go. So this also works here. I can do the same thing with the average. I can do the same thing with the minimum value. I can do the same thing with the maximum value. And I can do the same thing with count. So how many ages do we have? We can also just say count everything. So how many entries do we have? But if we have null values like this one here, so if I go for the p height, then I only get 10 because this is not counted as a valid entry if I go for a specific column. Yeah, so those are aggregate functions. We can also say, for example, I want to have the average height for, so I can say average height from people where the gender, so the p gender equals male. And then I get the average height for males in my data set and also for females here. So those are two separate results. Now I can also, by the way, or actually I cannot do this here. So this would just give me one value for male, one value for female. Now, if I want to list the category, or if I want to group by, this is already saying what we're going to use here. If I want to group by a certain attribute, so for example, I want to group the data by gender. I want to separate it into male and female. Then I can apply the aggregate functions on the different groups, on the different subsets. So what this means is I can say here, for example, average of p underscore h, or height maybe, like this, from people. And then I can say group, let's maybe do this in a new line here, group by, and I can specify that I want to group by gender. And what this results in is, and actually I have to also specify the gender to see this. What this actually results in is I get two outputs, male, female, and the respective average. So we group by a categorical attribute, for example here, the gender, and then I have for the individual subgroups that I have here, the average, or the sum, or the minimum, or the maximum. So this is what we can do. And we can also group by multiple attributes. So I can group by gender, and I can then also group by age, and this would result in male, female, and so on. And actually, I also want to print the age here. This would tell me, okay, males of age 55 have an average height of this, and so on and so forth, as you can see here. So we group first by gender, and then inside of the gender, we group by age. That's what this means. All right, so this is the group by. We take, we group. Now, what you cannot do is you cannot just print the height in this case, because this results in an error, because you either have to group by the attributes that you're showing, or you have to use an aggregate function, because what we're doing here is we're grouping by gender, we're grouping by age. Then of course we can just show the gender and the age, but the height is now no longer a value that we can that we can show for individual people. We have to show it with respect to a group. And because of that, we need to aggregate it in that group. And for this, we use, for example, average. All right, so that's the group by statement. And another thing that we can do is we can also order the results. So we can say, for example, select everything from people, and we want to order by, and we can say, for example, age. And then you can see we have 22 up until 89 in ascending order. I can also add a descending here, DESC, to get it in descending order, as you can see. And again, I can also order by two attributes. So I can say, for example, here I have 55, 55, 55. Now in this case, they are already ordered. Maybe I can order by name then. So I can say first by age and then by name in ascending order. So you can see now I have Anna, Mike, Samuel. So when you look at the first letters, it's now in order inside of that age category. I can also do it the other way around. Then we're going to prioritize the name. So if I say P name first, PH second, that would mean first sort by name. And if we have the same letter, then we sort by age. But in this case, we don't have it because, not just the same letter, the same name. In this case, we don't have it because, yeah, all the names are different. So if we would have 6 Annas, they would be sorted by age. That's the idea here. And finally, what I want to show you is we can also limit the output. So we can say, for example, select everything from people, limit, limit 5. And then I would just get 5 rows. And this makes sense if I do something like where, or maybe select from people, order by PH, limit 5. Then I only get the 5 youngest entries here. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.